when naming alcohols, we must remember that alcohols have the OL ending to the name with the OH attachments. Our first example will simply be a straight chain alcohol. Now, with alcohols, the OH is given the lowest number possible. So for example, we had CH3, CH2, CH2, OH. We would label this carbon number 1 and give the OH the lowest number group. There are 3 carbons total, making it a prop. And it's all single bonds, so it's a propan with an OL because of the alcohol group. The alcohol is at number 1, so we would call it propanol. Now, if we had a 4-carbon structure, CH3, CH, CH2, CH2, OH, we would call this 1,3 butanediol. 1,3 butanediol. Di signifying 2, all signifying alcohol groups, butane, 4 carbons, lastly 1,3 signifying the position of those alcohol groups. Listed are several common name alcohol structures. You must be able to recognize those on the exam. For example, benzyl alcohol, grain alcohol, or wood alcohol, ethyl alcohol, sec-butyl alcohol, and isobutyl alcohol. All of these structures are from the basic formula. In other words, isobutyl alcohol takes isobutyl and at the attachment point adds an alcohol. Some of the trivial names, as those were common names, are ethylene glycol, or antifreeze. Another one, glycerol. It's a solvent used for drugs, which we have recently gotten into in lecture. Some structures that need some delving into are phenols. So, a sample phenol problem is based off of our benzene ring, and a phenol has this OH attachment, as we mentioned in the last video. So, if this is our phenol, let's say that at this position we had this attachment. Now, how would we name this? Remember that our alcohol takes precedence, so our alcohol would actually form the last name. So, because of this functional group here, gives us the OL. This is a benzene ring with no direct carbon attachment, which gives us phen. So we have our phenol base. Now we have to name this functional group here. There are 3 carbons, so we know it's a prop, and in their arrangement, we know that it's an isopropyl group. So we would call this 1, 2, 3, and feel free to pause the video and take time to do it, but this would be 3 isopropyl phenol. 3 isopropyl phenol. Now, some of you may ask, why don't we have to put the number 1 for the OH on the phenol group? This is because when we're naming phenol, and we use the name phenol, we automatically, as organic chemists, assume that the alcohol is on position number 1. Now, another group that uses oxygen for naming are the ether groups. Now, for ethers, as you remember, you have your R, O, R groups. Ethers are very simple. You name this group, you name this group, and then you write the word ether. So if this were called group 1, and this were called group 2, this would be 1, 2, ether. An example of this would be if we had CH3, CH2, O, CH3. You don't have to worry about alphabetizing, but this would be an ethyl group and a methyl group, so we would call this methyl ethyl ether. There are a couple of basic alcohol reactions. In this next video, we will go over reduction and oxidation. For the sake of this video, we will go through fermentation, hydration, and dehydration. Fermentation takes glucose in the absence of oxygen and creates ethanol plus carbon dioxide. That's an equation that you'll have to memorize for your exam. The next reaction is hydration, which is the opposite of dehydration. So in hydration, you take a double bond, add H2O with acid, and you get an alcohol molecule. Dehydration takes that alcohol molecule and goes in reverse and gives you back the double bond. Those are your basic alcohol reactions. In the next video, we will thoroughly go through oxidation and reduction.